And last here, a couple things to talk about. Okay, before we go, what I got? About 6 minutes. Permutations. Just kind of extending your vocabulary a little bit here. You've been doing permutations already today. Okay, what we've been talking about are permutations. Permutations are simply the number of ways you can arrange items in a certain order. Okay? When we were arranging the letters in Burke's name, we were arranging them in a certain order. We were doing permutations. Okay? Permutations are simply the number of ways you can arrange items in a certain order. You have to put them in a certain order, though, when we're talking permutations. Okay? Order matters. Order matters. So that's permutations. All right? Everybody got that?
Yeah.
Okay? Another thing that we will use, okay, is the NPR function on our calculator. Okay? We will use the NPR. Okay? P stands for permutation. Okay? P stands for permutations. But NPR, when you see that, okay, that represents the number of ways that N objects can be arranged R at a time. The number of ways that N objects could be arranged R at a time. Alright, so here's what I brought up. Let's say we got 8 people running a 400. Alright, so we got 8 people running around the track. And I asked this question. How many ways could they finish first, second, and third? Or if it was the Olympics, how many ways could the medals be distributed? Okay? Well, that's different than me saying, how many ways could those 8 people finish the race? Because when I said how many ways could all 8 people finish the race, that answer would be what? 8!
8 factorial.
8 factorial. Okay? Appreciate it.
You're welcome.
If I said how many ways could all 8 people finish the race, it would be 8 factorial. But I'm just asking you, how many ways could they medal? Could they get gold, silver, bronze? How many ways could they finish first, second, and third? So now, I'm not arranging all of those things. I'm only arranging some of them. I'm only putting the first 3 in order, because I don't care how they finish after first, second, and third. Okay? Yeah, you all ran, but you don't get anything. Okay? All right? So that would be an instance where you would use, pay close attention to this, guys. That would be an instance where you could use NPR. Now I say could use because you don't even have to. Okay? You could do 8 NPR 3. Okay? Because there are 8 total people running the race, but you're only putting 3 of them in order because you only care about finishing first, second, and third. So you could do 8 NPR 3 to get your answer. Now, how do you do that? Well, most of you that probably noticed when you, or maybe you did, maybe you didn't, but if you go back to where that exclamation point was on your graphing calculator, you'll also see NPR as a choice there too. So what you could do is you could type in your 8, then you hit math, go over to probability, PRB, and choose the one that says NPR. Press enter on that, and then press 3, so you're doing 8 NPR 3, okay, and then you'll get your answer for how many ways they could finish first, second, and third.
So is 10-1 all just going to be on the calculator?
Most of the stuff's all on the calculator, yeah. Now, okay, another way that you could do it, and this is pretty important here, okay, because I'll be honest, I probably don't use NPR very often unless the numbers get big. In this situation, I'd probably just do 8 times 7 times 6. Because think about it. How many ways could we pick somebody to get first place? 8. There's 8 people running. How many different people could finish in first? 8. Okay. How many different people could finish in second? 7. How many could finish in third? 6. 8 times 7 times 6. That will also get you the right answer. Okay? Reason being. Okay? Reason being, okay, NPR, the math behind this, when you do this on your calculator, the math behind this is n factorial divided by n minus r factorial. That is the math that gets done. Okay? So when you do 8p3, okay? Guys, please pay attention. When you do 8p3, your calculator is doing this. 8 factorial divided by 8 minus 3 factorial. Which is really 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What's 8 minus 3? 5, so 5 factorial. 5 times 4 times 3 times 2 times 1. Cancel, 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 cancel. What's left? 8 times 7 times 6. Okay? So, you're saying, well, why do you even teach this? Okay? Well, what if we had 100 people running some cross-country race, and I want to know how many different ways the first 18 people could finish? Well, if you want to do 100 times 99 times 98 times 97 times 96 times 95 times 94 times 93, if you want to do 18 numbers multiplied together, you go for it.
Yes.
Fun.
Or you could do 100 NPR 18. That's just a lot faster. NPR is kind of like a shortcut to the multiplication counting principle. Now, if you're only multiplying 3 numbers together, well, I'd probably just multiply the 3 numbers together. That doesn't take very long. Okay? Just like factorial was the shortcut to figure out how many ways you could arrange all 26 letters in the alphabet. You could do 26 factorial instead of actually taking 26 times 25 times 24 times 23 all the way down to 1. Okay? So NPR and factorial are kind of shortcuts to doing the multiplication counting principle. Okay? So, you should be able to do a lot of your assignment, but not all of it. You should be able to get to 41 pretty easy. Okay? Which is quite a long ways. So you should be able to get to 41. I'd like you to try and get some of that done before Wednesday. Okay? The expectation